When dealing with the integral of the product of two functions, we apply integration by parts. So we have 5 forms that we'll be dealing with: the logarithmic, the inverse, the algebraic, the trigonometric, and the exponential, abbreviated LAED. So we are integrating a function of a form f at x, g at x, dx. We'll have to keep f at x constant. We integrate g at x dx. We subtract by the integral of the product of the derivative of f at x with the integral of g at x dx. Suppose we were to integrate the sine inverse of x dx. Remember, this can be written as what? The integral of sine inverse of x multiplied by 1. So now it shows me clear that I'm having two functions. You know that whenever I'm going to multiply the sine inverse of x with 1, I'll always have the sine inverse of x. So what form is the sine inverse of x and what form is 1? Sine inverse of x, if I can check from LAED, it is inverse, which it comes before 1, which is algebraic. So it means that that sine inverse of x is your f at x. You just plug into the formula. When you see f at x, you put sine inverse of x. And when you see g at x, you put 1. So I'm having sine inverse of x integrating 1 dx minus the integral of the derivative of sine inverse of x integrating 1 dx. So what is the integral of a constant 1? It's x. So this becomes x sine inverse of x minus. And you know very much well, when dealing with the derivative of sine inverse of x, is always 1 over the square root of 1 minus x squared multiplied by the integral of this, which is x. Don't forget this dx that you see here. So now we have applied integration by parts. So, but we still have to simplify this part. And for this part, we might use another method or use the integration by parts. So let's see for this part. I need to integrate x over the square root of 1 minus x squared dx. There are two other methods which I'm going to apply to integrate this besides integration by parts, because it's going to complicate things for me. Here, I use integration by parts, yes, but for this one, I'm going to apply either U substitution or trigonometric U substitution. But the one that I'm going to go with is the trigonometric U substitution, because I know most of people understand U substitution, but when it comes to trigonometric U substitution, it's kind of like a problem. So let's continue. I'm going to draw a triangle. When I draw this right angle triangle, here is my angle U, and here I will have x, and I'll let the hypotenuse this time to be 1. So if I apply Pythagoras in this right angle triangle, I can find the adjacent side of angle U being given by 1 minus x squared. And if I can check clearly on the triangle, I can see that the sine of U is nothing but x. And also, the cos of U is nothing but the square root of 1 minus x squared. Why is this the case? You know, the sine of an angle is the opposite side over the hypotenuse side. And also, the cos of an angle is the adjacent side over the hypotenuse side. Please take this in note. I will need this for me to apply the trigonometric U substitution. So, according to you, trigonometric U substitution, in order to integrate this, because I'm having a form a squared minus x squared, I'm going to let x to be a sine u. And my a in this time it's 1. Since a squared it's 1. You must understand that. So let's proceed. If I let x to be sine u, it means I need also to differentiate x with respect to u, so that I can also express the x in terms of u. So the derivative of x with respect to u is the cos of u. So making the x the subject, it means your dx becomes cos of u du. Then I'm allowed to substitute to this integral of mine. Meaning, whenever I'm integrating x over the square root of 1 minus x squared dx, where I see x, I will put sine u. That's it. So, let's see. The square root of 1 minus sine squared u. This you can see is the trigonometric identity, which is nothing but cos of u. If I proceed with this, so I have sine u cos u du divided by the cos of u. So from here you see cos u cancels cos u, and I'm left with the integral of sine u du, which you know is nothing but negative cos u. And as I've explained to you, what was cos u is the square root of 1 minus x squared, meaning the integral of x over the square root of 1 minus x squared is nothing but negative square root of 1 minus x squared. And this one is true because if you are going to differentiate the negative square root of 1 minus x squared, you will find x over the square root of 1 minus x squared. And then we have the solution for that integral that we're given. Remember, we're integrating the sine inverse of x. So, meaning the final answer is x sine inverse of x plus the square root of 1 minus x squared. Remember, this part is the one that we're having here. I just replaced by its integral, which is this. Then you see negative times negative becomes positive. That's it for the integration by parts.